25. AMC 8. Question 22. A classroom has a row of 35 coat hooks. Paulina likes coats to be equally spaced. So there is the same number of empty hooks before the first coat, after the last coat, and between every coat and the next one. Suppose there is at least one coat and at least one empty hook. How many different numbers of coats can satisfy Paulina's pattern? This question you probably get a sense is going to be about number theory, but the hardest part for this question is to actually understand what is this requirement and how do I turn this requirement into some equation. So we actually need to draw this out. Let's assume hook is it's a line, and coats will be, let's see, a triangle, just for simplicity. So before the first coat, there are some hooks. So I'll draw one, a line, and some dots and a line, which means I don't know how many hooks are there. There are some. And after the first one, same thing. Some, and then another coat. Again, now I don't know how many coats are there, but I know after the last coat, there are some hooks. So get this picture first and do a quick double check. There are something before the first coat, something after the last coat, and between every coat and the next one, there are something. And there is at least one coat and at least one empty hook, which means the number of hooks cannot be zero. All right. Now, what do we not know? We do not know how many hooks are in each block, so we can assume this is A. We do not know how many coats are here. So by the way, if this is A, this is also A, this is also A. And then we don't know how many coats are here, so we're going to assume there are B coats. What we do know is the whole thing has a length of 35. Now, how do you use A and B to get 35? Well, B codes means there are B blocks. If you think about each of this as a block. So there are B blocks, and for each block, the length is A plus 1. Make sure you include a quote. So A plus 1 times B. And don't forget, after the last coat, there are A hooks. So I need to plus A. This is equal A to AB plus A plus B, and this is equal to 35. Here, A and B are both positive. And actually, you need them to be natural numbers. This notation just means they belong to natural numbers, so positive integers. All right, now this is a very traditional or very standard number theory question. You get the equation, and the requirement is the answer has to be integer. How many solutions are there? AB plus A plus B is a very special equation. So if you have seen it before, you will know this trick. If not, you will know from now on. AB plus A plus B plus 1 has a very special factorization. It is equal to A plus 1 times B plus 1. Easy to prove, just expand A plus 1 times B plus 1, you'll get AB plus A plus B plus 1. But it's super useful because plus 1, you get a factorization. Two things multiplied together, and this is equal to 36. So now what you need to do is to figure out how many ways can you write 36 as two numbers times each other, and those two numbers have to be bigger than 1. Be careful. 1 doesn't work. So 1 times 36 doesn't work because that means A is 0. And we can give it a quick try. So 2 times 18, 18 times 2. They both work. 3 times 12, 12 times 3, 4 times 9, 9 times 4. And lastly, 6 times 6. So we have 7 ways to do this. Answer is D.